We have the power is work done over time taken, which is force times distance over time. But now, if you remember, this distance over time or displacement over time is what? Velocity. So from here, we can say that distance over time is velocity. So power is force times distance over time. So force times velocity. And what's velocity here? V. So where force is F is force, V is velocity. Yes, and so we can say power is what? P equal to FV. That's the first one. Then we also have another one, which is work. Work, which we say work is equal to force times distance. Work is equal to force times distance. So that's F times X. Fx. So work is force times distance. But I talked about energy, and I said that energy is the ability or capability to do work. So energy can be potential energy, energy can be kinetic energy. So if it's potential energy, now the formula is mgh. If it is kinetic energy, the formula is half mv square. So if it's potential energy, the formula is mgh. If it's kinetic energy, the formula is half mv square. Different types of machines or examples of machines. We have the lever, we have the inclined plane. Now if you check this inclined plane you are seeing here, now this inclined plane is more of like something that is inclined at an angle. So you see the way this is inclined now. Inclined plane, we have the lever, we have the inclined plane, we have the gears, we have the hydraulic system. So we have the pulley system. So we are going to take this, what we have now, step by step. The lever, the inclined plane, the gears, the hydraulic system, and the pulley system, step by step together. So we'll move on to another part, which is the load and effort. So we'll talk about load and effort right away. Load, which is L, we have the load distance, which is XL. Then we have the effort, which is E, and we have the effort distance, which is XE. So this L now, the load, and we have the load distance. We have the effort, then we have the effort distance. So just try to take note of these two and use it easily. Understand that you are applying a force. This effort now is like a force. This effort now is like a force. But this load now is like an object. This load now is like an object. But this effort is a force. And this XE you are seeing here now is distance. Firstly, like I said before, we have that mechanical advantage is equal to load over effort. Then we have velocity ratio. Velocity ratio is equal to effort distance over load distance. So that's the first thing. Then we have that work output is equal to load times load distance. Now load times load distance is L times XL. Then work input is equal to effort times effort distance, and this will give us E times XE. Now we have something called efficiency. This is the formula for efficiency, the unit for efficiency. So we can say efficiency is equal to work output over work input times 100%. So we are trying to know how effective the machine worked. So we can just come here. What was work output? L times XL. What was work input? E times XE. But now if you observe very well, now we are having something different here, times 100. So we know that load over effort is my mechanical advantage, but what we have here is XL over XE. Now remember that velocity ratio is XE over XL. So that means if we want to have XL over XE, it will be 1 over velocity ratio. So 1 over velocity ratio from what we have here, 1 over velocity, like I said before, in this case 1 over velocity ratio will give us XL over XE. So what we have here is XL over XE, right? So here we already know that this is mechanical advantage, but here now we know that this is 1 over velocity ratio times 100%. So meaning that from what we have here, we're going to have that efficiency is equal to mechanical advantage over velocity ratio times 100%. So that's just it. Efficiency, this efficiency now, efficiency is equal to mechanical advantage times velocity ratio times 100%. So mechanical advantage, this MA now you're seeing here, MA, mechanical advantage is MA. In the next part, VR, which is velocity ratio, so this one is velocity ratio, this one is mechanical advantage. So you can see now we now have the efficiency is equal to mechanical advantage over velocity ratio times 100%. Take note of this.